Assalamualaikum warahmatullahi wabarakatuh, and very good evening. Ladies and gentlemen, first of all, I want to say thank you for the best opportunity to present our paper in this good event. The title of the paper is Autonomous Mobile Robot, or we can say EMR, designed with behavior-based control architecture using adaptive neurophagy inference system or ANFIS. Paper is authored by Andi Adriansa, Eko Isanto, Khairul Anam, Sigit Indrianto, Andika Baihaki, and Julpri Andika. First of all, I want to say about robotics technology. That the robotics technology is the most advanced technology fields that covering various lines of life, such as the industrial sector, education, health, transportation, climate, defense and security, and entertainment and tourism. The robotics technology also covers various other subfields of sciences, such as electronics, mechanics, informatics, design, geology, health, and others. But there are so many problems in robotics education. First, we need to discuss robot parts, so many parts in more detail. Some parts of the robots is electronics, mechanics, informatics, hardware, and software. Also in robotics, we need special control architecture. This control architecture will process some inputs that based from some sensors to know the situation or condition of the environment. And with special control architecture, these inputs will generate some outputs as a robot movement. The accuracy of the robot movement is based on the performance of control architecture. And the other ones, the robotics also have a problem that the robots should know the fundamental process in robots working. There are so many processes in robots, such as perceptions, localizations, path planning, and motion control. Because of that, we need to develop special robot or special autonomous mobile robot. This paper will try to propose some special autonomous mobile robot. The methodology that we use in design of the robots set as behavior-based control architecture. The control architecture that, as explained before, is a serial processing. Some serial processing that operates on a cycle. The cycle will do first is sense, to sense some condition, some situation based on the environment. And this sense result will try to generate a plan based on this sense and some logic. And the plan will develop an action, an action of the robots as a movement of the robot. And these three process will have a cycles to do the robot's movement. And then the behavior-based control architecture, let's see in the next figure, is a biologically inspired and also distributed and bottom-up approach that decompose the problem of autonomous control by tasks. It means the problem will decompose of some tasks rather than function. The robot that use behavior-based control architecture will decompose. Yeah. Let's see the figure 1. The robot will decompose the task into several modules. Yeah. And each of the modules we said or we called as behavior. Yeah. Let's see in the figure 1 this. Yeah. There are so many behavior. Yeah. The behavior is based on some sensors, yeah, to generate some action. Yeah. If the robot have so many tasks, we can also able to decompose the tasks with some behaviors. Yeah. Each behaviors, let's see this figure 1, will generate some response based on the stimulus, yeah, as a result of the sensors. And all of behaviors result will coordinate in some behavior coordination. The final one, the final action is based on the coordinator of all of the behaviors. Okay, before we design the control architecture, first we also have to design a robot model. We try to design the robot based on the circular robot model, yeah, that placed in the X, Y coordinate Cartesius, have two wheels, yeah, with some radius, and also the robot which have a diameter in some measurement. The movement of the robot is based on principle we state as differential drive principle. Yeah. There are some linear velocity of the robot and also angular velocity. Based on this differential drive principle, we derive some dynamic system of the robots, yeah, that will move the robot from the XC to the XC plus 1, and YC to the YC plus 1, and the theta C to the theta C plus 1. This dynamic system will move the robot every one particular time. Also, we modeling some processing of the robot, such as goal-seeking processing, that the robot have to go from one position to the goal position. And based on this situation, we try to make a calculation from the initial position of the robot, and we try to make to calculate the distance and the angle from the initial position of the robot to the goal position of the robots. This variable d and delta will calculate the control architecture of the robot. Okay, we go to the design of the proposed design. Yeah. All of the behavior, yeah, we try to make a control architecture based on UNFIS. Based on UNFIS, this is the structure of the UNFIS with some layer 1, layer 2, layer 3, layer 4, and layer 5. And we can see also in the figure, there are block diagram for all of the robot. Let's see that the robot have 4 sensors: odometer, color sensors, right zone sensors, and also front zone sensors. This sensor is will do some behaviors like goal-seeking behavior, color detecting behavior, wall following behavior, and also obstacle avoiding behavior. All of the behavior, such as we explained before, will go to the robot motion control based on the model as we explained just before. Yeah. And the robot motion control will generate some movement with a motor driver and DC motor and servo motor components. Yeah. Ladies and gentlemen, we go to the UNFIS design. For the example, we design an obstacle avoidance behavior. First, we go to the data normalization. We make a data as an inputs and the outputs of the system based on the obstacle avoidance behavior. And the data we go input to the ANFIS simulation, yeah, using MATLAB, and we train the data. And after we train the data, we testing the data. And based on the some error value, we can get a better ANFIS structure. Yeah. This is the ANFIS structure as a result. Yeah. Well, we can see that the structure have a 3 input, and we also can see the membership function of the input and the role and also the output members function to generate a result or the final control value. Yeah. This ANFIS structure, as a result, we input to the robot system that we make using Arduino. Yeah. And then we try to experiment the movement of the robot for each obstacle of behavior. For this explanation, we can see the one of the behavior. There is obstacle avoidance. We can see that the robot able to do the moving. For example, if there is no obstacle in front of the robot will move forward, yeah, because there is no obstacle. Yeah. And if there is an obstacle in front of the robot will start to doing obstacle avoidance behavior and make a decision and will go to the better direction. For the example, in this experiment, we can see that the robot will move turning right. Yeah. Because in the right of the robot is a free zone that the robot will able to move. Yeah. The other experiment, also there is obstacle in front of the robot, but in the left one, there is no obstacle and the robot will move to the left one or moving the turning left. Yeah. For the last one, we go to the conclusion. Based on the some experiment and some data, we can say that the design of an autonomous mobile robot using behavior-based has been performed. Its behavior is controlled by implementing ANFIS. Fuzzy logic parameter optimization is done based on the minimum value of MSE, RMSE, and MAPE. Yeah. And the best result from the fuzzy logic parameters were tested on the robot to see the performance of movements in each behavior. Based on the activity of the robot, it can be said that all behaviors work with good performance, where the robot can avoid obstacles, detect colors, follow some walls, and also able to decide the direction of movement. And the last one, the further research can be carried out to improve the existing behavior coordinating system and also able to increase the accuracy of the control system for each behavior. Ladies and gentlemen, that's all for me, and thank you for your attention. Thank you very much.